All right, we did it. We're live. Jonny has it nailed.
Got it figured out.
You got to figure it out. We now have smooth, consistent introductions. That's why we have Jonny. That's his value add. Nothing else, of course. Never insightful questions. Never useful domain knowledge. Nothing else. Just the intros.
I click things that open other things.
That's it. Why am I the person in focus? How do we make it? Jonny, can you make us all equal? This is I don't know how to use this software. Jonny does it for me. Anyway. No, not that one. That one's never mind. No. I give up. I'm sorry I ever asked.
No, it's weird. I always do this. There we go.
There we go. He found it. All right. Good afternoon, morning, GitOpsians, wherever you actually are. It's still morning for me. We are joined today by my colleague, Eric Fried, from the Hive team here at Red Hat. Hive is a pretty neat tool. It does GitOpsy things. But before I let Eric actually start speaking and doing more than looking pretty, just quick announcement that I forgot 2 weeks ago and finally remembered. And that is that I am speaking at Cloud Native Security Con in Seattle at the end of June. So June 26th, 27th. And there's a link going into the YouTube chat. I'll do it in a second while Eric's speaking, to the talk to see what the topic is. It's about addressing the OWASP top 10 security vulnerabilities with cloud native tooling. So, and I'm joined by my colleague Ali Reza, who is a CSA. Ooh, I'm the worst. Yeah, CSA, Cloud Success Architect here at Red Hat, for that talk. We're excited. We're looking forward to giving it, and hopefully, if either you're attending the event live or if you are going to catch the recording later, we hope that you enjoy it too. That said, that's it for the announcements. Eric, hi, welcome. Thanks for coming.
Hello, my name is Eric Fried. I work on Hive, and I think what is going to happen now? Do I just start? Am I just going to start talking?
Yeah, it's your show now. This is you.
All right, awesome. So Hive is a project that is it's open source, like many things in Red Hat. It is a thing that knows how to provision and manage OpenShift clusters. We call the place where Hive itself is running the hub, and we call those clusters that it creates and manages, we call those spokes in the vernacular here. So I'm going to kind of just give a quick and rough overview of what Hive is and what it does and who uses it and that kind of thing. Encourage questions and whatnot. So I'll just get started. This is the repository. I think Hill's going to start putting links into wherever those links go in case you want to follow along in your browser. The homepage of the repo has sort of a stub documentation that links off to the various other bits of docs, some of which I will be going over. The main usage doc, this using Hive doc, is probably the good starting point if you really want to get a more thorough overview of what happens here. But I'll be kind of going over some of the high points of this. Who uses Hive? We have a number of internal consumers for this, one of which is managed OpenShift. So if you, which we call OpenShift dedicated, I'm not sure what the world calls it, but managed OpenShift, if you come in and ask for a managed cluster through cloud.redhat.com and our SREPs are going to manage it for you and whatnot, then the technology under the covers that does the provisioning of those spoke clusters is Hive. The OpenShift dedicated organization runs a number of hub clusters, and then they have some software that sits on top of those that knows how to spray the configurations out to distribute them across those hubs. And then Hive takes it from there and starts provisioning those clusters for you, provides back the necessary credentials, and that interface is then funneled back to you as the user. Another internal consumer that we have is our CI. Internally, we write a bunch of software and we need to run continuous testing on that software. And a lot of that testing is around OpenShift. And so in order to run those tests, the test configuration will spin up a cluster, and then you run your tests. Your configuration runs your tests on that cluster, and then we tear down the cluster and we're done. For certain of those tests, we provide the ability for you to ask Hive for that spoke cluster that you're going to run your tests on, mainly through the use of cluster pools, which I'll be talking about a little bit more later on. And then one of the other main things that you may have actually heard of and used if you're external is there's a product that Red Hat sells for actual money called ACM, Advanced Cluster Manager. I should probably learn what that stands for. And it supports a wide range of different kinds of spoke cluster installation and management. And the subset of those that Hive knows how to deal with is dealt with by Hive. So Hive is a subcomponent of ACM that is probably running under the covers when you are requesting spoke clusters through ACM.
Yeah, we've, just for audience reference, and I'll try and find a link to it. We've shown ACM on this stream before, and so if you've seen that or you're thinking, wow, hub and spoke sounds familiar, it's because the terminology is in fact shared. That's kind of lucky. It hopefully helps keep it straight. Eric, you are 2 minutes in, and you already have 2 questions.
Hit me
in the chat. So the first question is, and you feel free to defer these to later if you're going to get there, right? The first question is, are there any plans to make Hive rotate certs?
Great question. No. We have cards that, open for this. There's actually been a fair bit of discussion about this lately, and the answer is that it's not. Hive isn't really the place where this should happen. It really should happen at a layer above Hive. I agree that it would be a really useful knob for Hive to have, but fundamentally Hive is a Kubernetes operator. So like its job is more of a reconcile the state of the world to match what the declared configuration looks like. And rotate certs is kind of an operation like do this thing once. Now, I know that this sounds a little contradictory because install a cluster is also kind of a do this thing once thing. But if you think about it in terms of make it so that there is a spoke cluster that looks like this manifest, then then I can sort of justify that being more of a reconcile the desired state kind of setup. It is possible that something like this would be implemented at more the ACM level. In the meantime, if you wanted to rotate certs, you would need to go do it on your spoke. And there are actually things that, there are actually knobs on Hive that you could use to facilitate that if you wanted to. It's kind of an awkward path through it, but you could use sync sets to do some of the work for you. But then you would also have to replace those certificates in the kubeconfig secret that Hive uses to communicate with the spoke cluster. And that's kind of the part where some higher level orchestrator would be more appropriate to do that kind of operation.
Well, I'll let Alan come let us know if there's any follow-up questions. Same person, different question. And I feel like, first of all, you and I had this conversation a couple weeks ago. So obviously it occurred to more than just me and one other person. I will say, caveat this with, for the folks who are really new to this topic, we've already talked about sync sets and happy deploy clusters. Maybe we may be jumping ahead of ourselves. So I'm going to let Eric answer this with the hope that the context becomes clearer as Eric actually starts developing the Hive story a little bit more for the audience.
Yeah, and I'll I kind of recognize some of these questions as coming from people who already understand Hive pretty well. So I kind of am seeing that this is that you're seizing an opportunity to kind of get these burning questions that you've been sitting on for a while addressed. So CAPI, the cluster API is like just saying CAPI. It is so many things. It's kind of a grab bag of a bunch of different cluster setup and configuration things. There is a vision that there's one vision that CAPI could just replace Hive entirely. Like CAPI could do all of the things that Hive does, so you don't need Hive anymore. There's another vision that Hive could if you like Hive and you're used to Hive or you're used to ACM or whatever, that those technologies could wrap CAPI and kind of put the polish on them and make them a little more user friendly, and and make it so that you can migrate from your existing workflows more seamlessly without having to like go and redesign. Now you go from creating cluster deployments to now you're creating CAPI manifests and having to do that transition instead. Hive or ACM would do that translation for you. I will say that we're in the we're still kind of in the formative stages of all of that. And part of the reason is because, at least from an OpenShift perspective, CAPI isn't mature yet. It's not mature enough it certainly isn't mature enough to replace all the things that Hive does. So it's at least the answer to this is, for a hot minute, Hive is going to continue being Hive. Now, installer, I believe I'm not violating anything by saying this because the installer is also a public repository, but the installer is putting in paths where they will be deploying clusters using CAPI technology under the covers, as opposed to the existing paths via Terraform. And that the transition to that, so Hive runs the installer under the covers. The transition to that should be invisible. Now that's just for standing up the cluster day 0. For day 2 operations, there are opportunities for integration at various points along the way. I'm gonna leave it at that unless there are follow-ups.
There was totally a follow-up, but I'm gonna tell Alan to hey, let us get this story developing, because there are definitely people I know watching this stream who don't have all of your great contextual knowledge. I appreciate you. Stop taking so much advantage. And it's the only time I've ever said that. But so the question was, couldn't Hive just become a provider for infra for CAPI?
Yeah, no, it'd be the other way around.
No, I want to. Okay, we'll come back to the other way around comments if we have time.
Yeah, sure.
I do have a quick question.
Yep.
I'm sorry. So just from the Red Hat side, right? We use hosted control plane, hypershift, right? It sounds like it does something very similar, but it also sounds like Hive is completely separate. So then, if you look at it from a big picture perspective, ACM fits in as this would be the top level of an umbrella, right? Like the management umbrella. And then you'd have Hive as a provisioner, and then HCP as a provisioner, and then whatever else, right? Is that am I thinking about that the right way? I'm just thinking Legos. Okay.
Yeah, absolutely. And that, so kind of, I sort of referred to that a little bit earlier in passing, that, Hive will do the parts of ACM that Hive knows how to do. Hypershift or hosted control planes is another subset of what ACM knows how to do that Hive doesn't know how to do. And again, this was kind of there was a fork in the road early on with Hypershift where are we going to make Hypershift part of Hive? And we decided the answer was no on that. So, from that point of view, ACM is the umbrella. Hypershift is one of the things under that. Hypershift knows how to create hosted control plane type clusters. And then Hive is a separate thing that knows how to create what I would, I guess, by contrast, refer to as standalone clusters. That makes sense.
We call them classic.
Yeah.
Classic
is what we call them. So it's like ROSA HCP, ROSA Classic.
Okay.
That's just what we call them.
So this is where they appear more like traditional, right? Where they're using where maybe hosted control plane is using STS completely with AWS. This would be using the cloud credential operator as it was,
yes.
Right? It's not using. Okay, got it.
Yes.
Thank you.
So the thing, the alphabet soup you just mentioned. So STS is not a thing in Hive. The way to think about the distinction between Hypershift and Classic is that in Hypershift, Red Hat owns the control plane, whereas in Classic or Hive deployed clusters, the control plane nodes are in your infrastructure, in the customer's infrastructure.
Got it. Yeah, that's perfect.
Sense?
Yep, absolutely.
Okay.
Thank you. That was awesome.
Great. More questions before we move on here?
No, I'll get back to Alan's last question.
Okay.
Cool. I think it's going to come up in your story, and I'll interrupt you at that appropriate time.
Okay, sounds great. All right, I will quickly show how to install Hive in case you're following along at home and you don't want to use ACM or you don't want to use cloud.redhat.com and get yourself a managed cluster. we have this installation guide. So there are two paths that I want to highlight. For the console-y types, you can go to Operator Hub. You can search for Hive, and you can install it this way as a community operator. We boost, so the alpha channel is the only one we're maintaining right now. We boost this weekly. And I'm gonna take this opportunity to say that Hive is the agilist project that I've ever worked on, possibly that I've ever heard of, in the sense that we actually produce a GA product with every commit. We don't publish to OpenShift or to Operator Hub on every commit. We do this weekly. Mainly, that's kind of just a tool, like an overhead thing. Somebody has to push a button, and then rather than and yes, we could probably automate that, but we do this. We give ourselves a week at a time to kind of vet and make sure things are going smoothly. That is, by the way, the same cadence to which we promote builds to managed OpenShift. So every week, managed OpenShift is getting a refreshed version off of our master branch. So that's one way to install this. For the more command liney folks among us, we also have, let's see, I think under developing, and again, I think Hill's going to put these links in the wherever they go. This is going to tell you how to clone the repo and build things locally, and then push images to your image repository, and then run a make target that will deploy it to your hub cluster, which, by the way, can be OpenShift, but also can be we're designed to run on things like Kind. Like any Kubernetes should be able to run as a hub.
That I can confirm.
Yeah, I can confirm.
It runs on AKS.
Yeah, I can confirm that it runs on Kubernetes because we don't test that way really until we break something. And then very quickly, somebody writes us an issue in the GitHub repository that says, "Hey, this doesn't work anymore," and we go fix it. So,
I know this is a dumb question. At least it feels like it's a dumb question. But do y'all use Microshift at all, like to test some of the spin up, like to do something like device edge?
We do not. First of all, we cannot install Microshift spokes. That is one of the things one of the variants of OpenShift that we do not handle. Can we run the hub on Microshift? I don't see why not. I don't know that anyone has tried it.
That might be worth a project.
If you are listening,
I might kick the tires on that.
Do it. Absolutely. Let us know.
Yeah.
Microshift is Kubernetes compliant, right? So it should work. We'll see.
Yeah.
The fact that you're asking the question and that I don't know the answer either means that nobody's tried it and therefore nobody cared yet, or that it works just fine and we haven't had any complaints.
It's one of the two.
Definitely the latter.
50-50.
Definitely the latter. Works every time, 100% of the time.
Yeah. So question that just came in. So how exactly do ACM and Hive differ apart from the Red Hat hosted control plane? Or is Hive an upstream version of ACM? So
Hive is a subcomponent of ACM. So ACM knows how to do 10 things. And of those 10 things, and that's an arbitrary number, of those 10 things, Hive knows how to do 4 of them. So when you ask for any one of those 4 things, then ACM calls to Hive to do that thing. When you ask for the other 6, ACM calls into something else to request that. An example is hosted control planes, right? As we were talking about before. So if you ask for an AWS classic cluster, then ACM is probably going to go and ask Hive to build that for you. If you ask for an HCP spoke, then ACM will go and ask the hypershift code to do that instead. Hopefully that answers the question.
We'll find out if it doesn't.
All right. Okay, next thing to talk about. Hilliary asked me to show an architecture diagram for people who are into this visual type stuff, which by the way, I'm not, in case you haven't sort of figured it out yet. If it's a picture, then I like gloss, my eyes glaze over and I don't know what to say, but we'll be doing some console work later on. So when you install your hub cluster, you install Hive into the hub cluster. We're gonna create a namespace and we're gonna install some controllers into it. And those controllers are responsible for reconciling CRs, right? Custom resources, Kubernetes custom resources that we define. And the main one of those, the main driver for dealing with spoke clusters is called a cluster deployment, which I'll go into in a little detail in a minute here. Once you create a cluster deployment, we have an admission controller that makes sure that it's internally sane, that you didn't, spell things wrong or whatever, or omit this field that's required because you specified this other field. That's kind of the normal admission stuff. And then if we accept it, then the controllers will take that cluster deployment and run with it. And the cluster deployment sort of defines what you want your spoke cluster to look like. And so we will go and we'll spin up a pod. In that pod, we will actually run the OpenShift installer. So in that sense, Hive is kind of just wrapping the OpenShift installer binary that you would otherwise be running from your laptop or whatever. That install pod again runs the installer, which goes out to your infrastructure and creates the machines on your infrastructure and installs OpenShift on them. Creates all load balancers and other things that I don't understand, right? And makes your cluster an OpenShift cluster. And then we have various other, so like in the process of doing that, it's going to need a secret that knows how to access your infra, right? So this is your AWS account, for example. It also needs a pull secret, which is the OpenShift thing that authorizes you to access the images, the software itself that OpenShift comprises, and a couple of other things, right? Where this doesn't show everything, but this is the sort of the big picture. And the point here of Hive is, as a fleet manager, it can do this part of the picture, right? Installing and creating a cluster multiple times. And are there theoretical limits to how many it can do? I think we might have a document somewhere that says that you can run 2,000 of these on a hub, or possibly ACM has even tested that far. I'm not fully sure. I can tell you that in our managed OpenShift environment, that we routinely run 500 spokes off of a single hub, and those are fairly busy from the point of view of things like sync sets, which I'll talk about in a minute. So certainly, we can handle in the hundreds of spokes per hub.
Awesome. So question came up. This is Alan's second time asking this question, but this is exactly where I was going to kind of chime it in. So thanks for re-asking it, Alan. Does Hive create the kubeconfig secret, or if not, what does?
Right. So when we run the installer, at the end, if you've run the installer yourself before, you know that at the end of the install process, it emits a kubeadmin password and also a kubeconfig dump. And so we just extract that from the installer output, and then we Hive create the secret, the kubeconfig secret that we Hive then subsequently use anytime we need to contact the spoke cluster. So I'll actually show a little bit of this. I'm not going to dump the contents of secrets, obviously, but if you can see, I have I've pre-created an eFreed cluster. The AWS creds I had to provide before we started. The install config I had to provide before we started. The pull secret I had to provide before we started. And am I in the wrong place here? I may have deleted the wrong thing. You can see that for example, for another cluster here, we have an admin kubeconfig secret. I think I know what happened here. I'm gonna have a problem later with my demo.
I so say the demo gods happened. They
demo
reached down
gods,
their hand.
That is
and
exactly.
Was like, your sacrifice was insufficient. We're going to mess up your plans
here's what I'm going to do instead here. We're going to try to create another cluster, see if I can get it working by the time I need to demo sync sets, which actually is the only thing that's going to cause a problem for me. Yeah, so the reason this happened is, and I really honestly, I didn't think that we deleted that secret when we deleted a cluster, but I was going to demonstrate adoption. And all right, cool, great.
We can just skip adoption this week. We can always do it again in the future if we decide we want to go deeper into Hive.
Actually, adoption is the thing that will still work. Sync sets is the thing that won't. But we can. I'll figure out a way to muddle through it. So what I did here was don't do this at home, but unless you're of the more of the hacker variety. But Hive util is an internal utility that you can build off of the Hive repo. We don't support this as for customer use, but for internal use, I can run Hive util to create cluster. This will actually generate all of the things that I was talking about. It pulls the AWS creds from an unknown location. It generates an install config based on a bunch of defaults or on the command line flags that I provided. It pulls the pull secret from a known location in my file system and so forth, right? And it's just a shortcut to getting a spoke cluster starting to set up real quick. So since I had to go and do that, let's take a look at what's happening here. So the controllers are busily reconciling all of the stuff in that cluster deployment object. You can kind of follow along and see what all of the things that are happening in here if you like. That's from the so the pods that are running in there per that architecture diagram. So we have the one that's doing most of the work here is called Hive controllers. And then if we take a look, you can see that we have a provision pod that's running, and this is where the OpenShift install binary is actually running. So this, if you've run the installer before, you kind of recognize this as the normal sort of, hey, I'm doing this stuff with Terraform and setting up the resources on the spoke. So this I had not intended to show you this, but since the opportunity presented itself, we'll put that way. Okay. So now I will do this. This is the cluster deployment that Hive util command generated. And so for those familiar with sort of the Kubernetes paradigm, this cluster deployment is a custom resource according to a schema of a custom resource definition that Hive owns. So we have this API version that sort of namespaces this and shows that we own it. And then the cluster deployment has in the spec section all of the things that you would need to specify that you need to in order to pass to the installer to create a cluster. So the base domain, this is eventually going to be an efread2.newinstaller.openshift.com is going to be where the console is going to live, somewhere under there, and all the API server and so forth are going to live under that domain name. I don't know why this exists already. You can tell I don't spend a whole lot of time looking at some of these fields, but something that I want to point out is that under the platform section, so we support several different platforms, AWS, GCP, vSphere, OpenStack, IBM Cloud are the big ones. There might be a couple more that are some of them are fading in and out of support or don't get used very much. But under this platform specific section is where you would put things that are going to be obviously specific to the platform. In this case, we have a reference to a secret that has the AWS credentials. The reason this is platform specific is because the format of that thing is known to AWS and it's not the same as for any other platform. And then, a region, which these, AWS cares about regions. So we have that in here and so forth. Everything else can kind of default. And then under provisioning, we have a reference to another secret that has the install config in it. And I'll actually go ahead and show you that. Oh, and then the release image. So this is your pull secret needs to know how to get to this thing, needs to be authorized to get to this thing, and the things that it refers to. So in this case, I'm installing a 4.14 spoke. And then the pull secret that I talked about earlier, right? So I'll go ahead and show the contents of this secret, which I vetted beforehand and made sure it doesn't have anything super private in it. So if I just show the secret, right, it's got the stuffs in it, and then I can say so the contents, if you're familiar with this, you'll recognize the compute section is going to define what my worker nodes are going to look like. The control plane, likewise for the masters. Some networking stuff, platform here. Don't get excited. This is my public key. So this is just what we feed into the installer to generate that cluster.
So question from the chat real quick, which is, since you showed a 4.14 cluster, the question is, is Hive already supporting 4.15 installs?
If it is GA'd, we support it. If you can get at the release image that I showed earlier, then you can install it. Anything that you can install with OpenShift install should work. Yeah. In fact, if you wanted to go have your own local repository for 4.6 or something ridiculous that if you still have all the binaries for that, there's no reason you can't give us that release image and we'll just do it. We don't worry too much about. So this is an interesting point, actually. Hive does not have any controls for what OCP versions we support. Obviously, we're restricted to what platforms we'll support and certain installation paths, but we do not restrict versions. That's sort of going to be according to whatever your support contract with OpenShift is.
No additional questions in the chat that we've missed, so I think you're good to keep going.
Fantastic. Okay, we did that. Okay, I will briefly talk about Hibernation. I can't really demo Hibernation without that secret in place. You know what I'm going to do? If I'm gonna throw my colleagues under the bus. Suhani and/or Mark, if you guys are listening and you want to back channel this, I'm gonna send you my kube config. Can you package my kube config and create the secret called this in the eFreed namespace on the Hive team cluster?
Hey, Eric, and while they're looking that up, we got another question that came in. It's about setting the VIP and API VIP.
1 second.
Yep.
This is why we have silent watchers in the background, right? This is the power of the team. The hive mind, if you will. You're welcome.
I love it.
I'm trying to think, because we talked about some stuff so far it's been really like AWS specific. And I'm trying to, I was thinking of talking about the installation, right? And the managed services, just for that perspective, the managed services, we do tend to have a very limited set of install targets. So you will be restricted if you're using one of the managed flavors of OpenShift to our like approved install target list. And there are ways to get that list. I'm not going to enumerate over them here, especially because I don't remember how to do it for ROSA because I haven't used a ROSA cluster in forever. But yeah, and in ARO we have our own as well. So just that's another thing. And we set those in the managed service, and Hive just does whatever we tell it to do. Because computers typically do what you tell them to do. Whether or not you told them the right thing is a different question.
Yeah. So, and just to kind of put that picture together a little bit. So that's going to be the OCM layer is what is kind of sitting in front of managed services there, and their job is to kind of be this user interface wrapper around all this stuff that's happening under the covers. And from that point of view, the set of supported releases would be effectively a drop-down list. So you can only pick from the blessed list of versions that way. Right.
That is how it works in ROSA.
Yeah.
We don't. OCM is opt-in on ARO. We have a lot of disconnected environments over there, so it's opt-in. In ARO, the Azure CLI, also the Azure UI has it too somewhere. I don't remember where, but I only ever do this from the CLI. The Azure CLI will give you the version availability, and you can select it there. Or if you don't pass us a version, we're going to pick our default install. That's how we do it.
Cool. Okay, so I will talk briefly about Hibernation, and then I may actually show I may be able to show a demo of that. Let me see if Suhani and Mark had a good idea, which is there are other clusters here on this cluster. So let's see. Good. That's a GCP one. That should work. Can I use, Mark, can I use this guy right here to show Hibernation? Let's give it a try. Yeah, okay. Got an ACK on that. So if I do this, I'm looking at that cluster deployment. There is a field in here that we didn't see in the previous one, and it is called power state. And this can take two values, hibernating and running. And since this is in the spec, this is what you declare that you want your state to look like. And so right now we're saying I want the state to be hibernating. So if I look down in the status section, the status section is, it's got all these conditions. Okay, so the status section is, here's what's actually happening. So if you look in the status section, it says, okay, we're actually hibernating right now. So what I'm going to do now is I'm going to edit that cluster deployment, and I'm going to change hibernating to running. And then what we should be able to do is see oh, failed to start machines. Okay, but what's happening under the covers is that Hive is trying to contact the infrastructure using the secret that is in that namespace and say, hey, go start the instances. Now, something went wrong here, of course, because we're demoing. But if we were to look in the cloud provider here, and I'll just show this because I already had the filter set up. But these are the instances from my two clusters, right? The one that I started with today, whose secret I lost, and then you can see that this one is still coming up. It's got a bootstrap node, and then it's creating its masters, and then so eFreed 2 will start to create workers as well when those are done. And as you may know, an install in AWS takes around 40 minutes. So I'm kind of expecting it to finish right around the time we're done here, which isn't useful. But now if I
Eric, before we move on, I'm sorry. I was if you could just go back really quick, just mainly because we talked about the difference between hypershift and Hive. Mm-hmm. So when you're looking at this console, right, like in hypershift, hosted control plane, for the product people that are out there watching me, you would never see these masters, right? You would only see the workers, right? Because that's all you see is the compute layer.
That's correct.
So that's a stark difference. And I think that you made the point earlier, right, where you own the control plane as a customer with Hive, and then Hypershift owns the control plane. Well, Red Hat owns the control plane in hosted in HCP or Hypershift. So just to point that out from an AWS cloud perspective, that's the difference that you would see in the console is that Hypershift, it's only workers, and then here you've got everything. Sorry, I didn't mean to interrupt you there.
No, that's perfect. And not to get off into a sort of a diatribe of the relative merits, but you don't have to pay for the masters in your infrastructure in that case, but you're paying Red Hat for them. Red Hat is able to spin up those clusters much more quickly because we don't have to provision the masters and install OpenShift on them. And then Red Hat is also able to consolidate some of the workloads and kind of run a bunch of masters together. Mm-hmm. So it's cheaper it's basically a lot cheaper for Red Hat, and then we get to split that cost savings with you.
Yep.
As the customer.
Bin packing, I think, is the term, right?
That sounds like a good term.
That sounds like that. Yeah, we basically bin pack them, and then there's some magic logic to decide when to move something or when to spin up a new hub to hold the control plane nodes for the hosted control planes and all of the other fun things that go into the actual orchestration of the service thing. I'm going to brag a bit on our Red Hat SRE team because this is a product and feature set that we directly contributed to the writing of and execution on. So it was obviously in partnership with the hosted Hypershift team, hosted control plane team, with the ACM team and so forth. But a lot of the feature set and stuff that was done in here was also done by your friendly neighborhood Red Hat SRE teams. And I cannot be prouder of the work that we have done there. So just a little humble brag on the team there. Great job, ROSA HCP folks on your GA last year.
+1. Yeah, good stuff. So this is Mark's. This is a cluster that Mark happened to be spinning up for some engineering that he's doing, and it just finished installing. So the Bootstrap node is terminated, right? That's going away, and you can see that we sort of set this up with a kind of a default configuration: 3 masters and 3 workers, and those are running right now. I'll just refresh that real quick. So I'm going to demonstrate Hibernation on this one. Because now, let's see, let me just go ahead and undo this thing that I did here. So now, this other one that was, a second ago, it was provisioning, 33 minutes. So now it's provisioned. That took a little less than 40, great. So now I'm going to go ahead and hibernate this one. So the field doesn't exist right now. So hopefully we will see in a minute that the state will start to change to stopping instances, and then eventually.
How long does hibernation and I don't know what they call the reverse wake up? I don't know what they call it. How long do those processes take? Resume. There we go. How long does that usually take on average?
On the order of minutes, 3 to 4-ish minutes. Shutting down takes so hibernating takes less time generally, and then resume will take about 4 minutes. So we have to start the instances. That happens fairly quickly, but then OpenShift has to grind into action. The nodes have to become healthy, and then we actually wait for cluster operators to look healthy. I think something may have gone wrong here because there are never any bugs until demo day.
I was just going to ask this question.
What's that?
So like when the nodes are coming, say you kept the nodes off or you hibernated for the weekend. I'm still in Suhani's thunder here a little bit. So say we hibernated on Wednesday, took a long weekend, came back on Monday, resumed the cluster. Like in the normal times, like the CSRs might be pending, right? Mm-hmm. Now, does Hive take care of that automatically, or do you actually have to go in, source the config, and then like approve the CSRs when it's coming back up?
in the case of CSRs, Hive actually takes care of that for you under the covers.
Okay. Awesome.
All right, here we go. So I'm not sure what happened there. Oh, you know what? I bet it was. I'll bet you're just provisioned Hibernate after kicked in, or something deleted that field. But it's okay. So we're at this point waiting for machines to stop, and we'll go back to the console and refresh this. You can see that it's stopping the instances. That'll take. Go ahead.
Oh, so that's pretty cool. This feels like a good time to interrupt you with the question that we can quite get to earlier about the VIP. So, Johnny, do you want to read this question?
Yeah. So, K&A is asking, can you assign the ingress VIP or the API VIP along with like the machine network stuff, or is it all basically predefined? Like it's just going to be what comes out of the cloud.
Oh, you're asking, can you bring your own IPs for AWS? And I think the answer is that is coming soon. But it's a question that is an OpenShift question, not a Hive question usually. So what happens is OpenShift will implement features along these lines, and then that'll sort of trickle down to Hive and say, hey, is there anything that Hive needs to do differently here to make sure that this actually works? And sometimes we have to make little tweaks here or there. So bring your own IP. We'll have to like ask that question through like your support channels, please, because they'll be able to answer it much more officially than I can. But I think that's a thing that is A, coming, and B, should be supported by a Hive in some fashion.
Yeah, if it goes into OpenShift, it makes its way to the managed services, usually really, really right away, because it's just we add some opinions on top of vanilla OpenShift. There's a few things that are different, but for the most part, it's you get what you get with OpenShift.
Mm-hmm.
All right. I'll let you get back to your agenda. We've had a lot of questions, and I appreciate all of them from the audience because obviously people are interested.
Well, let's hit a couple more. Oh, good. Failed to stop. I don't know what's going on with. Oh, that's the sorry. That's the other one here. We're still waiting for something to happen in here. The instances you can see have already stopped. We may just be waiting for another poll to come back on this cluster. But it should be getting there fairly shortly. But this would be a good time for more questions while we're waiting for this to kind of settle out.
Can you do standard deployment stuff? Like I see you have the 3 right? Control plane, 3 control plane, 3 machines. Can you do like a single node, like 3 node compact cluster where you have like the control plane and the computes? This
is a great example of where there's a line kind of between what Hive knows how to do and what other things have to handle. You can adjust the number of workers and masters to some extent, but unless you are doing the special thing called single node OpenShift, there are minimums. I think you have to have a minimum of 2 workers and a minimum of 3 masters. Don't quote me on any of that. But if
3.
you are, is it 3? Okay.
If you are availability, yeah, and that's required.
But if you're doing Snow, that's a special thing. And what that actually runs through is a thing called assisted installer. An assisted installer is kind of this weird hybrid. It's a wrapper around Hive so that you can use Hive primitives to talk about, so you can still view your fleet that has some assisted installer stuff and some Hive stuff. You can still view it all through the Hive CRs. But under the covers, rather than running the OpenShift installer, it's sort of a plugin model where we offload the installer process to whatever AI decides to run. I shouldn't say AI, whatever assisted installer wants to run. So does that answer your question?
Yeah.
Okay.
Speaking of alphabet soup, right? All of the repeating acronyms that you only can know what they mean based on context clues.
Yes.
We're good at those in this company. We're really good at
overloading.
Totally.
Yes, overloading everything.
And what's super fun is that everything has to start with RH, right? So you already have extra letters in there. Okay, so we can see that this actually went to hibernating state. I'm going to go ahead and edit it again and resume it. And we will say, you'll see that it's starting machines, waiting for machines. This will go through a few more states as we continue to chat. And then, the last one that you'll see should be one like this, pausing for cluster operators to settle and then waiting for cluster operators. So it makes sure that things that are registered as cluster operators, which deem themselves important enough to be that, they will, once they become healthy, then we will declare the cluster running. While that is,
this is an awesome feature.
Go ahead.
I'm sorry.
Yeah,
I'm sorry. I'm excited. This is awesome.
No, please. So actually, thanks for keeping me going on this, because I'm showing you what this is, but I didn't explain why it exists. Based on somebody smarter than me did some studies on this, and an AWS cluster that has its instances stopped, you still have resources that you're paying for out there, and I think like NAT gateways are still up or something like this. There's some stuff that's still happening, but a cluster with its instances stopped costs approximately a third of a cluster that is where the instances are running. And so that, to your point, if I am done with my stuff for the weekend and I hibernate on Friday night, then when I come back on Monday morning, I've spent a third as much over the weekend as I would have, but I don't need to wait 40 minutes for my cluster to install, especially if it's got some state that I wanted to preserve, or I just don't want to wait 40 minutes to create a whole new one on Monday morning. Then now it takes me 4 minutes to resume instead of 40 minutes to install a new one, and however long to get up stuff into it or whatever.
Yeah. So like
hit the button and make coffee.
Right.
Yeah. Yeah, exactly. And before I came over to my current role, like that's what we were doing, right? My customer, they were essentially a service provider for their customers, right? And so they would spin up clusters for them, and then the idea was like, like that customer would pay them for the cloud. They're like a managed service provider without being like Rosa or ARO, but they were trying to figure out a way to hibernate or to shut these clusters down over the weekend or holidays and stuff like that. They were trying to solve this problem.
Yeah.
As well as like the quick automation of like redeploying like a hypershift and like Hive, something that I could use like Ansible or GitOps or whatever to spin these things back up if I had to.
Well, that's a great segue into cluster pools. So a cluster pool is a thing where you can give me a install config template, which is most of an install config. And you can tell me what version of OpenShift you want. In this case, I'm using an image set, which is just a little metadata wrapper around a release image URI. And then you provide like a couple of the same things that you see in the cluster deployment, including your cloud credentials, your pull secret, and so forth. And then you tell me how many of these would you like? And how many of these would you like me to keep running? So I have created, in this case, I used fake clusters just to make this a little bit quicker, but I've created this pool with size 2. So now there are,
oh, that's cool.
Now there are 2 cluster pools that are sitting here waiting to be used. Running count was 1, so this one's running. So now when I do what's called a cluster claim, I'm going to grab one of these running ones, and then the cluster pool itself is going to refresh back to so that it always has 2 on standby, right? Or two clusters in the pool, and one of them will always be try to run. So if I do, the reason that there's 3 is because I made a cluster claim earlier, and it claimed one of the pool clusters earlier. That's this one. And so now I would use this cluster until I'm done with it. And then I would, delete the claim, and that will automatically delete the cluster. So you'll see it's deprovisioning that one.
Now, do you do this all as cluster admin, or can you set it up to where Johnny as a normal dude can come in and just create cluster claims or whatever?
Yeah.
Or
so we ship with some roles that you can bind to users that let you do these things. Or you can roll your own, right? Because because cluster pool is a Hive CRD, you can create your own role bindings or cluster role bindings that allow your users to create cluster pools, or just to view cluster pools, or create cluster claims and delete cluster claims, and so forth. So and that's in fact the use case that I mentioned earlier with OpenShift CI. They have cluster pools that are running. And as an admin, as the maintainers of OpenShift CI, they can go in and mess with cluster pools and do administrative things to them. But as a user, as a consumer of that CI environment, as somebody running tests, you are supposed to be able to go in and view the cluster pool that you have created via GitOps in our repository that does such things. And then you would have the ability to you wouldn't be able to edit things, but you could view things. At the behest of that tooling, you can run a CI job that will, under the covers, on your behalf, create one of these cluster claims, and then in whatever namespace that generates is going to hand off to you that cluster, and now you own that cluster. And we do all the RBAC under the covers that gives you access to that cluster deployment, and only that cluster deployment within the context of the whole thing. So if I do, let's see if I can find this thing. I've got a so I can create a cluster claim, and really I just have to give it the name of the pool and the correct namespace, and then I'm using generate name, so it's going to give it a random name. So if I do create one of those things, then you can see that it automatically grabbed this one, the running one, from the pool. And then we still have the same situation going on, except now we have none on standby and one at the ready. So what we did was we resumed this one from Hibernation, and then we should also be provisioning a new one. Now I'm using fake clusters, so they provision very quickly, but you can see that it started v whatever, is now running, and then it created a new one and put it in hibernating state. So by balancing the size and the running count, you can have sort of the expected number of clusters that are ready for you to claim immediately, that you don't need to wait to resume. And then we'll kind of resume one in the background so that the next one will be ready instantly. And then we'll provision another one so that it can be hibernating and on standby and waiting for that whole cycle. So by balancing those various counts, you can, to whatever your workload is, you can have clusters that are as cheap as possible, but also as readily available immediately as possible.
And so just awesome. To clarify, and we have 1 minute left, and I'm okay with going over if you are, Eric, but I want to be respectful of your time. This is, you drink your champagne on this, right? This is how you are able to do your CI/CD in such a way that you can release every commit.
Yeah, for sure.
Okay.
So we eat our dog food from the perspective of cluster pools. We take advantage of that CI tooling that has cluster pools running on CI owned cluster. And when we submit, we have a couple of our jobs that claim clusters from the pool via the mechanism that I just described, and then run our tests on those clusters. And in fact, because we're Hive, we install Hive on those clusters. So that spoke cluster becomes a hub also. And then we use it to deploy spokes as well. And in fact, we have a test that creates a cluster pool on that spoke hub that then creates spokes off of that, as you know. So yeah, it's all
little inception. The reason I mentioned this is this is for like this is like for the folks at home who are like, okay, this is cool, but like I don't see what I do with it if I'm not Red Hat. That's what you do with it if you're not Red Hat, right? I mean, there's other things you can do with it too, and if we're going to go ahead and stay a little long on the stream, and so that we can get to the other cool GitOpsy things. But this is one of the hardest things to solve, is on-demand-ish infrastructure for CI/CD, so that you can be a truly, like, this is real continuous. This is the actual, when we say CD, like, this is the real thing. Mm-hmm. It's the only project I've ever tangentially worked. I'm gonna say I worked alongside, because I haven't worked on it. It's the only project I've worked alongside that actually does do every single commit.
Yeah. So questions about cluster pools. See, Johnny, you have something. Can you have Hive and HCP on the same cluster side by side? Yes, you can. ACM does that exactly. Okay. Now, when you say that, it's using side by side on the hub. So yes, they'd be on the same hub.
Okay.
And yes, I think that anytime you install ACM and you enable both of those things, that's what's happening.
This is so awesome. Like there's yesterday nerd, right? When I was in consulting and I was like trying to solve the same problem. And Hilliary, you're 100% correct, right? Like this is a hard problem to solve. And like we were doing it from a different perspective other than CI. Like we were doing the CI part of it, but like it was really for like how do we enable our customers and then make it efficient for them. So to see it in action is just this is awesome.
Yeah, this is the peer behind the curtain. This is how we do the things.
Well, I'm delighted to hear you all say that. If y'all don't mind going over a little bit, obviously I want to be respectful of your time. Also, there's a couple more things that I can show here. Once again, I'm going to steal Mark's cluster because. And of course, because we're demoing the resume didn't work properly, I'm going to blame Mark. I'll go rake him over the coals later.
Yeah, it's absolutely his fault.
Totally kidding. So sometimes if things aren't working, then you can kind of hibernate and re-resume them, and things will start working again. But
the good old turn it off and back on again. I knew you still had that S3 mindset in you.
Absolutely. Yeah. So I will show briefly this thing. A machine pool is a Hive concept where the thing that sits on the hub designates a configuration for the machines, the worker machines that you want on your spoke, and then a replica count, much like a replica set or deployment would. And then on the spoke, this will get reflected as machine sets. So I'm showing two different clusters here, but the point is that if I were to go and take this, change it to replicas 4, then what you would see over here is that 1D would start to spin up 1, 1, 1, 1, and spin up a new machine and add that to the cluster. You can also turn on auto scaling in here and give it it'd be a section called auto scaling with a min replicas and max replicas that would then create automatically a cluster autoscaler and machine autoscalers on your spoke. And then the autoscaling software takes over, the OpenShift software that does that takes over, and based on your load will create and delete machines and nodes. Questions about that?
No.
Cool. And then the last thing I want to mention, and this is where I got myself in trouble, is a thing called adoption, which is, I'm going to go ahead and do this.
And this was my request because I think this is neat. That was Eric was like, why adoption? I was like, I just think it's cool.
Yeah. So if you do this, so normally if you were to delete a cluster deployment, we take that as you are telling me that the desired state of that cluster is for it to be gone, and we will go and deprovision it. But you can do this special thing called preserve on delete, which is I want Hive to quit managing my cluster, but I don't want it to go away, right? So if I do this, if I set that thing and I do then it'll delete the cluster but it'll leave the infra around, which he says as he then is now concerned that it's actually deleting the cluster. It doesn't matter. It's a test.
So bye-bye.
Yeah.
This demo's for you.
Right. But it's not doing that. I'm actually not sure why it isn't going away right away. But what it's supposed to do is go away right away when I say that. And I'll figure out why it didn't later. But then what you can do is, I saved earlier, I saved off the cluster deployment earlier, and with certain fields filled in. So normally if you create a cluster deployment with installed true, we won't let you do that unless you've also told us some other things about it, including like its infra ID and so forth. So if you were to save off like these identifiers beforehand, the easy way to do this is by saving off the cluster deployment manifest. And then you create this cluster deployment again, then we will adopt that cluster, which means we will assume management of it as if you hadn't ever deleted it. And so this doesn't just mean that I would do that. I would delete a cluster and then reinstate it from the same hub. You can do things like I can delete it from here and then go install a different hub and adopt it from there. And now I'm using it over there instead. So you could essentially migrate the management of a spoke cluster from one hub to another, kind of thing.
So if you you can also do, so if you've never had Hive before, but you have, let's say like you have 5, 6, 60 OpenShift clusters, right? That you're not a Red Hat, so you don't use Hive. If you decided to make a hub cluster, you can then adopt your fleet into Hive, correct?
Yep, as long as they are the same kind of clusters that Hive knows how to manage, then you should be able to adopt them. So if you installed them using OpenShift install on one of the handful of platforms that we support, as long as you know the infra ID, as long as you have, obviously you would have your cloud credentials, but as long as you have your kubeconfig, right, still to it, then you could create one of these things. You'd have to create those couple of secrets, and then yes, you'd be able to adopt all of those clusters.
If you get the networking magic correct, this is a big if. If you get the networking magic correct, can a Hive hub in AWS manage AWS, Azure, and on-prem spokes, or some multi-hybrid architecture?
Yes. So in the hub, we don't care. So as we mentioned earlier, the hub is allowed to run on any Kubernetes, and it will then manage any combination or distribution of the platforms, of spokes on platforms that we support, on the versions that we support. So thanks, Suhani. In the managed OpenShift environment, we have, at the moment, I think we have AWS and GCP spokes that we're running, but and then we have other environments that are running, Azure spokes or whatever. It is not necessary for them to all be separate hubs. They can all be running together in theory. So just real quick on adoption, we have a document, it's a section under the using Hive, which is kind of the main, like I said, our main usage doc that describes how you do this. And so this, you'd create this cluster deployment that has to have these certain things in it, these identifiers, infra ID, and so forth, and then the references to the secrets. And then it shows you how to make those secrets that are necessary. And
so this is cool because if you have an existing fleet and it's across, and of course, if you're a Red Hat user and you use ACM, then you already are getting this. But if you have a Red Hat fleet that's across multiple clouds, then this gets into like the most GitOpsy thing Hive does, even though I didn't ask you to prioritize it, right? Then you get to use sync sets to normalize your clusters across all the clouds with one thing, which is the most GitOpsy piece. And if you're ready and willing, we can get into that.
Yeah, so I'll just talk about it real quick. I did have a little demo set up for this, but hopefully this will suffice. So Hive has another couple of CRs called sync set and selector sync set, and they're substantially the same thing. They're just made for slightly different user models. Sync set is a namespace object that it only operates on cluster deployments that live in that namespace. A selector sync set is a global object that you can give a label selector, and it will operate on any cluster deployment anywhere on your hub that matches those label selectors. Otherwise, they do the same thing, which is to take objects that you designate either inside of that sync set or that you refer to from your hub cluster and make them exist on the spoke cluster. So this example that's in the document, if you put under the resources section a group object, then Hive will create this object as if you did an OC create on the spoke cluster. And then it will keep it in sync also. So periodically we'll go check and say, hey, does this still look like what we expected it to look like? And if not, we'll update it. And the other two modes that you can use here is you can take an existing object and put just a JSON patch on it. So like you don't want to declare what the whole thing looks like, and you like don't want to worry about did somebody else change this other section, but I know I want this piece to look like this, then you would use a JSON patch. And then because secrets are special, and because of, RBAC wise, you may want to give a user the ability to view or edit sync sets, but you don't want them to be able to see your secrets. We have this separate mechanism for syncing secrets down. So you could bundle the secret in here if you wanted to, but then anybody would be able to see it. So instead, you can create that secret on your hub cluster, and then in a namespace and give it a name, and then tell us where you want to put it on the spoke cluster, and we'll sync that secret down. And then we have a couple of different ways to apply these resources in such a way that either when you delete the sync set or you delete the paragraph from your sync set, either we will delete the resource on the spoke or we'll leave it alone. So that's if you say upsert versus sync here, and that's described in the document. And then let's see if I can. So the way that you sort of get the status of these things is by looking at an object called cluster sync, which is one that you as the user aren't allowed to mess with. It's one that's generated by Hive, and it's just there to provide the status of the sync sets that you have requested. In this case, we're not seeing them enumerated because I haven't made any yet, but it would enumerate these under there's going to be a list under the status section that says, here's a sync set that you asked for, here's did it succeed or fail, and here's whether we're going to delete it or not when you delete it from the sync set. That was all of the things I had on my agenda.
Yay!
Happily take more questions if there are any. Or
I just have a comment. The secret thing about syncing the secrets to the spokes. I'm trying not to cuss here. That's freaking awesome. That is because that's honestly that's one of the great things about ACM, right? Is that you can set up a policy to generate the secret or to take a secret and push it out to the clusters.
Right.
And it's awesome, but it's kind of complicated, right? Because like the resource itself, like it just takes some massaging and just like understanding a little bit to do it. That's pretty damn basic. And I mean like basic in a good way, right? Like that's you look at it, you're declaring what I want, where I want it, and then you're saying go. That is dope. I love that. I think that's freaking awesome.
That's great. I don't know for sure if ACM uses policy to sync objects when it's talking to a Hive-owned spoke, or if it uses sync sets under the covers. I don't know if you can use. I think you can still use sync sets if you're using ACM. I don't think ACM prevents you from doing any sort of Hive CRs manually if you want to. So even if you're using ACM, look at this.
Yeah, because this is awesome. I mean, like we use policies, but this to me is way easier to understand. And this is something that you can walk somebody through and be like, hey, look, here's what we're doing. Here's where it's going. I love this. This is awesome.
Awesome. It's really gratifying to see somebody excited about this. It's rare that I get to talk to somebody for whom this is all new. So
yes.
Yeah, it's the
Nerd
rest
out
of
here. This is
us
a good one.
who've been here a while.
Did we lose Hill?
Oh, I didn't know if that was me or if that was her. It looks like we lost her.
Yeah,
Okay.
I was assuming that it was her because you didn't freeze and she did.
I was looking at so I have a smart clock right next to my desk because my AT&T will just decides to reboot sometimes, and so like whenever it freezes, I'm always looking down at my clock. But yeah, it looks like we may have lost her.
Okay.
Yeah, dude, this is awesome. Like there's so many things that like are I use hypershift all the time. I mean, like when I say it's pretty much all I use on a daily basis. And so to see this and to see like okay, I can actually there's more, right? Then like this seems very simple to use. So I'm excited to go and kick the tires on it and like I
Great.
I see the uses, right? I can see why it's a big deal and I'm excited. This is awesome.
Well, I'm looking forward to hearing from you and helping you with the tire kicking. So great.
Yeah, man. No, this is great. And you can see a lot of the similarities too, right? Which so I think if you're coming from hosted control plane, I'm trying to use the product names because I get in trouble all the time for it because I always use the upstream names. So
Yeah.
if you're using a hosted control plane and you're making the transition over, there are some subtle differences, but like conceptually, you guys have pretty much stayed in sync on how you're naming things and how you're laying things out in namespaces and stuff like that with your secret names and stuff. They're all very similar.
Well, Hive predates Hypershift by 3 or 4 years, and so when
Okay.
they were designing Hypershift, they deliberately made a lot of those things. Made a lot of the concepts in parallel, and early on we were like, well, why don't we just use the same CRs and stuff? And for reasons they decided to kind of go their own way, but in a lot of ways they sort of built on the lessons that we had already learned by developing this thing for a few years. And so that's why you see a lot of the similarities, and hopefully in the places where HCP differs, hopefully it might be better, if less mature in some ways. But yeah, that's kind of the history there.
Awesome. Yeah, it's been when you talk about deploying traditional clusters, classic clusters, right, and then going to this where now you're talking 10 to 15 minutes. There's limitations like with everything, but like it's very nice. The usage is awesome, and yeah, I love seeing this come this far. I love seeing the technology roll and mature and just get better and better and better. And to see this and to see that, and I can't wait. So
awesome, cool.
There's no more questions. It sounds like Hillary's computer crashed, so I don't think she's going to make it back. So if you want, I don't know if you have anything else that you want to talk about, or if you wanted to.
I'm happy. I'm done with my spiel. If there are no questions.
All right, awesome. Well, to the folks that are watching and the folks that are going to be watching, thank you very much. If you have any questions, feel free to reach out to me. I'm Jonny, JONNY, at redhat.com, and I will try and answer your question. And if I don't know the answer and it's for Eric, then I'll forward it on to Eric, and we will get your question answered. So it just may take some time. But yep, thanks for joining and thanks for watching. Eric, dude, I know you're busy, so really appreciate you taking the time to come on and talk about this stuff. This has been super enlightening for me. And yeah,
it's been a real pleasure.
I'm truly, genuinely excited about using this. So like, this is awesome.
Nice.
All right, awesome. So with that, I will see if I can find the right one, and we'll see you guys later.
There you go. Thanks.